Hi guys, as promised, here's a little water demos video. I will try not to talk too much. I just want to point out a couple of things, perhaps, before the test tomorrow. So I'll just go in order through the demos and just mention things that might be important. So the first station was this paper towel station looking at water versus oil. This, you should have seen the water sort of travel up. The paper towel, once it hit the little puddle, with the oil, you should have seen it not do that. So this happens, of course, because water is polar, oil is nonpolar, and since water is polar, it can undergo cohesion and also adhesion. So the molecules of water are adhering to the polar molecules of the paper towel. Next. So this one, you were looking at conductivity, so the ability to conduct electricity. The key thing here, hopefully, is that you saw that as we moved from distilled to tap water to salt water, the ability to conduct electricity increased because the salt water has ions that allow electricity, which is electrons, to travel through it. Okay, here you saw the water versus the oil, one where they were separate. So you had your two tubes. Here you had oil on top of water. And in the other one, you also sort of had oil on top of water. But since they were shaken, it was a little more mixed up. So what's happening in the second one is that oil and water don't mix because oil is nonpolar, water is polar. But when you shake it, the oil breaks up into these little tiny droplets. And so you get little teeny tiny droplets of oil sort of suspended throughout the water. It's called like emulsifying. If you're a cook, you might have heard that term before. So that's what's happening here. You're getting these little droplets all suspended. But the oil's sticking together because it's nonpolar. The water is sticking together because it's polar. This one, you should have seen that the temperature here, I think it started for most people at like 20 and it ended at maybe like 18. And for alcohol, it started again about 20, but then it ended at like 14 degrees, somewhere in there. So what you're seeing here is that it's taking much longer for the water to cool off. In the same amount of time, water only cools 2 degrees, whereas alcohol cooled like 6 degrees. Because water has a high specific heat, it takes a lot of heat to get it to evaporate, which is what's cooling down the thermometer. Whereas with the alcohol, it has a low specific heat, so it doesn't take very much heat at all to get it to evaporate. Okay. So these are just the questions about what we just talked about. our explanation is that water has a high specific heat. Okay, so next one is where you put the water onto the different surfaces: paper, leaf, paper towel, and wax paper. Hopefully you saw that the leaf was most like the wax paper. I don't know what that is supposed to be. Wax paper. And it should have sort of beaded up on the leaf. And that is because both leaf and wax paper were non-polar. The leaf has a special covering on it to help keep the water in so it doesn't evaporate. Next, you saw the capillary action, the thin tube within the water, and it should have been. So you should have noticed, hopefully, that once you looked, the level of water within the beaker was lower than that in the little capillary tube, because water adheres to the sides of the tube, and so it could travel upwards and sort of keep pulling water behind it. And of course, the organisms that use this capillary action or cohesion and adhesion are things like trees. They pull the water up to the top of the tree using these thin little tubes. Okay, the last one I'm going to talk about. You had the penny on the little petri dish, and then you dropped water on the penny first, and then you recorded soapy water. You should have found that with pure water, you should have gotten a larger number. I'm going to make up a number, like 40. Whereas with soapy water, you should have gotten a smaller number, let's say 20. Because the soap gets sort of in between the hydrogen bonds. And so it doesn't allow the water molecules to be held together as tightly. So you can't have as many drops using the soapy water. Okay, finally, there's the glass beaker with the ice. The ice should have kept the level the same because the ice was floating a little bit up out of the water when it was frozen. It would have been doing that. Here, if we get the outside of the beaker having water on it, the condensation, it's water from the air that is being cooled on the side of the glass, and so it's turning liquid from the gaseous air. So that's it for the water demos. Here are just a couple of things I wanted you guys to make sure you heard again before the test. So study hard.